Hey everyone, this is question number 63 from chapter 5. This problem asks us to determine the mean distance from Jupiter for each of Jupiter's principal moons. Using Kepler's third law, use the distance of Io in the periods given in table 5.3. Compare your results to the values in table 5.3. So I pulled up table 5.3 so we can see the data, and we're going to use equation 5.7b, which we've used already. I've derived in a couple, or showed you how to get it in a couple of the other videos, so I'm just going to go ahead and write it out this time. But it is r1 over r2 cubed is equal to t1 over t2 squared. And we can use this to find a relationship between, we're relating to radius of orbits and to periods of orbits. So we can solve this. In this case, we're going to leave T2 to be Io's data and solve for T1. So T1 equals, R1. We're solving for mean distance. R1 equals R2 times T1 over T2 raised to the 2/3. Okay, so this is going to be the equation that we're going to use for all three of these. So let's start with Europa. RE is equal to R2, which is Io, which is 422 times 10 to the 3rd kilometers, times 3.55 days. So the period of Europa, 355 days, divided by the period of Io, which is 1.77 days. And that's raised to the 2/3. And that gives us a radius of 671 times 10 to the 3rd kilometers. All right, that's for Europa. Now we can do Ganymede. Do not hold me to these pronunciations. So same equation, I'm not going to rewrite it. Ganymede equals 422 times 10 to the 3 kilometers times period of Ganymede 7.16 days divided by 1.77 days to the 2/3. That gives a period, not 23, 2/3. That gives a period of 1070 times 10 to the 3rd. Okay, last one, Callisto. RC equals 422 times 10 to the 3rd kilometers. And then period of Callisto, 16.7 divided by 1.77 days raised to the power of 2/3 equals 1880 times 10 to the 3rd kilometers. All right, so now just compare real quick. If you look at the table, these are pretty much spot on, really, really close to what we're given in the table.